Hey everybody, if you've spent any time on an RC forum or on an RC group on Facebook, you've seen a post that said something like, "Brand X servos suck. I just plugged in my brand new servo and it went to one side and then it died. So they sent me a replacement and it did the same thing. I'm never buying these crappy servos again." Well, yeah, that's what happened. And this video is going to explain to you why it happened and how to keep it from happening again. Okay, so there are two things that kill servos. The first one is too high a voltage. Think about it this way. If you have a 6-cell ESC and you plug a 12-cell battery into it, it's going to die. Well, the same thing with servos. Servos have a rated voltage. A lot of them are 8.4 volts. Some of them are 6 volts. If you feed 8.4 volts to a 6-volt servo, it's going to die. But when you do that, they just kind of die right then. You plug it in, pop, it's done. The servos that you see jump to one side and won't do anything and then die are being killed by something else. And they're being killed by an incorrect pulse width. Servos are controlled by sending them a series of pulses of voltage on the signal line on the servo. And the amount of time that those pulses take up determines where the servo is positioned from full left to center to full right. In a normal servo, the industry standard is 1520 microseconds for a centered servo. And you've seen this number if you've looked at the servo statistics and set up servos for your swash plate. That's your servos on your swash plate are 1520 microsecond. And the range of pulses for them runs between 1,000 and 2,000 microseconds. Tail servos, on the other hand, use a different center number. I'll show you an oscilloscope trace here that will explain pulse width a little better, and I'll talk through what the pulse width is doing. And then we'll talk about why tail servos and normal servos, plugging them into the wrong port, causes that one-side failure that we've been talking about. So this is an oscilloscope trace of a single PWM pulse that goes to the servo. And the length of this pulse, the right to left length, is approximately 1,520 microseconds, which is the center position for a standard servo. In order to move the servo to the left, we shorten this pulse. Now, you move your stick and your receiver shortens the pulse, like so, until you get all the way to the left. This is about 1,000 microseconds for a normal servo, and we come back to center, and then to move all the way to the right, we lengthen this pulse to about 2,000 microseconds. That's the range for a standard servo, between 1,000 and 2,000 microseconds. Tail servos work the same way, but they have a different range of acceptable pulse widths, between 460 and 1,060 microseconds, with a center at 760 microseconds. So what happens when we plug this servo into a receiver port that's putting out a 1,520 microsecond pulse? Well, the servo sees that as a command to go all the way to the clockwise rotation, and then beyond its limit of clockwise rotation, because we're sending it 1520 and it can only accept 1060. So if the servo sits there while you're configuring your flybarless system and playing around, you either burn up the motor or the motor controller or another component in the servo, and it's gone. So in order to avoid this, never plug a tail servo into a receiver. It always has to be plugged into a gyro or a flybarless controller. And never plug it into your gyro or flybarless controller until you have set the center pulse width for that servo in your flybarless or your gyro. And now you know how not to kill your tail servos. Have a great day.